In this video, we will define what is an eigenvalue and eigenvector and its procedure. Let us define what is an eigenvalue and eigenvector. So, if A is a square matrix and if there exists a scalar lambda such that Ax equals to lambda x, then lambda is called as an eigenvalue of a matrix A, and x is known as a eigenvector, and this x should be a non-zero vector. For example, so consider a matrix A of order 2 by 2, so that is 5, 4, 1, 2, and consider the non-zero vector x1, 1, minus 1, then write in the form of Ax1. So Ax1 equals to multiply with the matrix and the vector x1, so we will get resultant value as 1 time of 1 comma 1 minus 1, and this can be written as what? Lambda. So now lambda represents what? 1. So this lambda is equals to 1 is called as an eigenvalue of the matrix A. So let us see one more example. So if I consider x2 is a non-zero vector, so that is 6, 3, and if I multiply with the matrix A into x2 equals to, we got a resultant matrix as a column, so that is 42 and 12. So we cannot able to express it as a lambda times of this x2. So then this lambda 3 is not a eigenvalue corresponding to the eigenvector x2 is equal to 6, 3. Let us define what is a characteristic equation. The characteristic equation is obtained from the definition of the eigenvalue and eigenvector. So that is defined as what? Ax equals to lambda x. Here lambda is an eigenvalue and x is an non-zero vector, eigenvector. So this can be written as Ax equals to lambda. So we are writing in terms of a matrix. So lambda into I into x. So which is equals to x minus lambda into x equals to 0. Then take out the vector x common. So we'll get a minus lambda into x equals to 0. Then the det of a minus lambda equals to 0 is called as a characteristic equation. It is called as a characteristic equation of the matrix A. Procedure to find out the eigenvalues and eigenvectors. So the first step is find the characteristic equation. The characteristic equation is defined as det of a minus lambda equals to 0 to find out the eigenvalues lambda 1 to lambda n. And next, for each specified value of lambda, for each eigenvalue lambda, we have to solve the homogeneous system a minus lambda into x equals to 0. Then we will get a non-zero vector x. So this is a shortcut method to find out the characteristic equation of a matrix A. So and the matrix is now in the form of a 3 by 3 matrix. So it is given as lambda cube minus, so trace of the matrix here. So the trace of the matrix into lambda square plus this is the sum of the minors of the principal diagonal elements. So this is the principal diagonal element A11. So for its minor is what? So this is the det of A22, A23, A32, A33. In that way we will find out for each principal diagonal elements the minors into lambda minus det A equals to 0. So let us see an example to find out the eigenvalues and eigenvectors of a matrix A. So first we need to find the characteristic equation. The characteristic equation is given by the characteristic equation of a matrix A is given by det of a minus lambda equals to 0. So instead of finding that, so we will learn with a simplest form, that is lambda cube minus as the trace of the matrix. The trace is 8 plus 7 plus 3 into lambda square plus sum of the minors of the principal diagonal elements, that is, so consider the first principal diagonal element is 8. So neglect the column and row. So we will get det of 7 minus 4 minus 4, 3. This is the minor plus second principal diagonal element, neglect the row and column. So we will get 8, 2, 2, 3 plus next final last diagonal element, neglect the row and column. So we will get 8 minus 6 minus 6, 7 into lambda minus det A equals to 0. And so lambda cube minus 18 lambda square plus, so find out the determinant. 7 3s 21 minus 16, so 8 3s 24 minus 4, 8 7s 56 minus 36. Okay, so this is 21 minus 16 plus 20 plus 20, so total it is 45 lambda, and here we will get a determinant value as a 0, so which is equals to 0. So now find out the eigen values. So the eigen values are obtained as 0, 3 and 15. So these lambda values we will call it as an eigen values of a given matrix. Eigen values of a matrix A. To find the eigenvectors when lambda is equals to 0 and 3, 15, so we will see one by one. So when the case comes with lambda is equals to 0. Okay. So for that we need to consider the system. The system is what? Homogeneous system. So solve the homogeneous system. A minus lambda I into x equals to 0. Then what is x? Where x is an non-zero matrix, where x will consider it as what? X1, x2, x3 is a non-zero matrix. Non-zero matrix, or we can call it set vector. So write the homogeneous system. 8 minus lambda minus 6, 2 minus 6, 7 minus 4 minus lambda. So it is 2 minus 4, 3 minus lambda into x1, x2, x3 equals to 0, 0, 0. Okay. So now substitute in the case of when lambda is equals to 0. So put lambda equals to 0 in this case. So we'll get the matrix as 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3 into the column matrix x1, x2, x3 equals to 0, 0, 0. So this can be solved by using both, by reducing into echelon form or by using the cross method. So we learned the simplest way is the cross method here. By the cross method, so if you want to get the non-zero value of x1, so consider x1 by, so neglect the first row and first column, then the remaining elements make it as det, that is 7 minus 4 minus 4, 3. The second non-zero value is minus x2. Take it as for second one minus 2. So neglect the second column, first row, minus 6, minus 4, 2, 3. And for third non-zero value x3, neglect the third column and first row, you can write minus 6, 7, 2, minus 4. Det. Find out the determinants here. X1 by 7 3 is 21 minus 16, it's 5 equals to minus x2 by 6 3 is 18 minus 18 plus 8, so minus 10 equals to x3 by 6 4 is 24 minus 14, it is 10. Okay, so take out the common thing, so we'll get here x1 by 1, x2 by 2 and x3 by 2. So this is the vector in the case when lambda is equals to 0. So therefore write down x equals to x1, x2, x3 equals to 1, 2, 2 is a eigenvector for the lambda equals to 0, eigenvalue lambda equals to 0. So we'll see when lambda is equals to 3. When lambda equals to 3, the eigenvalue, solve the eigenvector. So write down the homogeneous system by substituting lambda equals to 3. So that is 8 minus 3 minus 6, 2 minus 6, 7 minus 3 minus 4, 2 minus 4, 3 minus 3 into the non-zero vector, that is x1, x2, x3 equals to 0, 0, 0. Okay. Then find its matrix, that is 8 minus 3 is 5, minus 6, 2, minus 6, 4, minus 4, 2, minus 4, 0 into non-zero vector x1, x2, x3 equals to 0, 0, 0. Now find out by using the cross method. The cross method. So to find out x1 value, neglect the first column, first row, and remaining make it as det. So 4 minus 4 minus 4, 0. Second, x2, neglect the second column and first row. The remaining values are minus 6, minus 4, 2, 0. And x3, neglect the third column, first row, minus 6, 4, 2, minus 4. So find its value. So x1 by 0 minus 16, so it is minus 16, minus x2 by 0 plus 4 to 8, so x3 by 6 4 24 minus 8, so it is plus 16. So take out the common from this one, minus 8, so we get x1 by 2, x2 by 1 and x3 by minus 2. So write down the eigenvector as x equals to x1, x2, x3, which is equals to 2, 1, minus 2 is a eigenvector for lambda is equals to 3, eigenvalue 3. So let us see when lambda is equals to 15. So write down the homogeneous system, that is by substituting lambda is equal to 15, 8 minus 15 minus 6, 2 minus 6, 7 minus 15 minus 4, 2 minus 4, 3 minus 15 into non-zero vector x1, x2, x3 equals to 0, 0, 0. Then compute it. So 8 minus 15 minus 7 minus 6, 2 minus 6 minus 8 minus 4, 2 minus 4 minus 12 into x1, x2, x3 equals to 0, 0, 0. Now compute by the cross method, that is x1 by, neglect the first column, first row. So by we get 80 equals to minus x2 by 80 and by x3 by, neglect the third column, on computing we will get 40. Now take out the 40 common. So we get here x1 by 2, x2 by minus 2 and x3 by 1. write down the eigenvector as x equals to x1, x2, x3. The non-zero values are 2, -2, 1 is a eigenvector for lambda is equals to 15. So this is a procedure to find out the eigenvalues and eigenvectors of a given matrix. Thank you.